Hello viewers, welcome to the e-learning platform of GYAN GURUKUL. Today we are going to study about some important results on circles. Okay, so before starting with those results, I would like to discuss that what does a second degree equation represents a circle. Ax square twice xy plus by square plus 2gx plus 2fy plus c equals to 0. This general second degree equation will represent a circle if the value of a and b is equals to 1 and the value of h is equals to 0. Then this general form will reduce down to this form: x square plus y square plus 2gx plus 2fy plus c equals to 0. I hope most of you know this result. This is the general form where the center is what? The center is minus g comma minus f, and the radius is obviously given by root over g square plus f square minus c. Clear? Now moving on to the first result. Result 1. In this result, we will study about the length of intercept that is being cut by a circle on a line. Fine? Say there is a circle. Okay, result 1 is related to length of intercept. Say this is the circle. I am taking it to be the simplest form. That means x square plus y square equals to a square, and there is a line whose equation is y equals to mx plus c. Fine. Then the length of this intercept cut by the circle will be given by the formula l equal to 2 root over a square 1 plus m square minus c square divided by 1 plus n square. If you can recall, during this last 2019 JEE mains, a question was directly asked from this formula. Okay. Next, if I am making it subcategorized, fine. If we have to find the length of intercept to a general circle, general means it's not the simplest one, it's this form where center is minus g minus f, then this length of intercept can be found if I draw a perpendicular from the center to the line. Say, let us name it as p. Then this is the radius. Then the length will be given by 2 times of root over r square minus p square. It comes very easily by the Pythagoras theorem. Clear? Now this was for general form of a circle, not the simplest form. Then the next result. If you need the angle between two circles, then what are you going to do? Fine. Now we know that circles are what? Curvical in nature. So how come we can find the angle? Actually, the angle between circles is the angle between the tangents at their point of intersection. Clear? Suppose these are the points of intersection A and B. Obviously, I can draw two tangents at this point. Whatever is the angle between these two tangents, that is said to be the angle between the two circles. Clear? So that angle, to find that angle, we will use the formula cos theta equals to r1 square plus r2 square minus d square divided by twice r1 into r2. Now what is this r1 and r2? r1 and r2 are the respective radii of the two circles, and d is the distance between the centers of the two circles. Clear? Don't forget what the symbols mean in this formula. Clear? So we have done the angle. Next, moving on to the next result. R3. This is said to be the condition of orthogonality. Now, dear students, orthogonality means, it means 90 degree. Okay? If the angle between two circles is 90, then we will say that they are orthogonal to each other. And the condition says 2G1 G2 plus 2F1 F2 equals to C1 plus C2. This is the requisite condition for two circles to be orthogonal. Next, result number 4. This result 4 is actually associated with the area of triangle that is being formed by the chord of contact with the pair of tangents. Suppose I draw any circle, okay, and this is an external point, say P, and from this external point I can obviously draw how many tangents? 2. That means a pair of tangents. Now suppose these are the points of contacts A and B. If you join this chord of contact, then you are creating a triangle PAB. Fine. Then suppose the radius of this circle is R, and the equation to the circle, okay, I hope you can see it clearly. The equation of the circle I am signifying by s equal to 0 instead of writing the whole log thing, okay. This entire left hand side we denote in shorthand by s equals to 0, okay. So I have got the form, the representation, the radius, the triangle. I need what is the area of this triangle. Then area of that triangle APB is straightforward, given by the formula R, S1 to the power 3 by 2 divided by S1 plus R square. Okay, S1 means, suppose the coordinates of this point is x1, y1, then S1 symbolizes the value of the left hand side when you put that point over here, okay. That means it will be x1 square plus y1 square plus 2gx1 plus 2fy1 plus c equals to 0. It's that very simple, okay. So this was the formula for area. Now next result is associated with the chord of contact, okay. Chord of contact means the chord which joins the the 2 points of contacts for a pair of given tangents. So suppose this is a circle and I draw a chord of contact, let us name it as AB, whose middle point is say M, x1, y1. Now if I draw the 2 tangents at the extreme ends, then they will definitely meet at some point C exterior to the circle, okay. Then we are generating what? A triangle named as ACB. Then the first thing comes is, what is the length of this chord of contact? The length of chord of contact will be equal to 2 root over modulus of S1. Why I am putting modulus? Because this point is interior to the circle, so S1 will be coming as negative. So to make it positive, I am putting the modulus symbol. Clear? Next is the area of the triangle. The area of the triangle ACB will be equal to R modulus of S1 to the power 3 by 2 whole divided by root over mod of S1 plus R square. That's very simple. These two formulas are little bit alike with them, okay, provided there is a root in the denominator side. So I hope if you encounter any kind of numerical associated directly to any of this result, you can do it in very less time. I assure you can do it within 1 or 2 minutes. Thank you for being with us. Keep watching our videos.